Okay, in this video we're going to be talking about the triangle similarity postulates and theorems. Now you remember in a previous unit we looked at triangle congruence postulates, and those were postulates that we used to show that two triangles were congruent. Well, the triangle similarity postulates and theorems are very similar, except we're going to be using them to show that two triangles are similar. And there are three triangle similarity postulates and theorems. The first one is called the angle-angle similarity postulate, and it's abbreviated like this, AA, and the little similarity symbol. And the angle-angle similarity postulate just says, if two angles of one triangle are congruent to two angles of another triangle, then the two triangles are similar. And this is probably the easiest of the three similarity postulates and theorems to use. Here I have two triangles, ABC and DEF, and I can see that this pair of corresponding angles are congruent. This pair of corresponding angles are congruent. So, since I have two angles in this triangle congruent to two angles in another triangle, then I can say triangle ABC is similar to triangle DEF by the angle-angle similarity postulate. The next similarity theorem that we're going to look at is the side-side-side similarity theorem. And it just says if the measures of all of the corresponding sides of two triangles are proportional, then the triangles are similar. So here are two triangles, again triangle ABC and triangle DEF, and I'm given the measures of all three sides of each triangle. And in order for these two triangles to be similar, then each pair of corresponding sides for these two triangles must be proportional. In other words, all of the ratios of the corresponding sides have to be the same. That's what it means to be proportional. So let's take a look at each pair of corresponding sides and see if the ratio of each of these corresponding sides gives us the same number. So let's see, we'll start out with AB to DE. So AB to DE is 30 to 25. And I can reduce that to, if I divide top and bottom by 5, that gives me 6 over 5. So that's this pair of corresponding sides. Let's look at BC and EF. BC and EF. BC is 24. EF is 20. And let's see, if I divide top and bottom by 4, then that gives me 6 over 5. So those two sets of corresponding sides are proportional. They both are equal. Their ratios are equal. And so let's try the last pair of corresponding sides. That's going to be AC to DF. AC is 18. DF is 15. And let's see, if I divide top and bottom by 3, that will give me 6 over 5. And so yes, I see that each pair of corresponding sides between these two triangles is equal to the same number, which means that they are all proportional. And since the measures of all the corresponding sides of both of these two triangles are proportional, then I know that these two triangles are similar. So I can say triangle ABC is similar to triangle DEF by the side-side-side similarity theorem. All right, let's take a look at the last of our similarity postulates and theorems. This is the side-angle-side similarity theorem. And the side-angle-side similarity theorem says if the measures of two pairs of corresponding sides of two triangles are proportional and the two included angles are congruent, then the two triangles are similar. Okay, so this one, it kind of adds elements of the side-side-side theorem and the angle-angle postulate to get the side-angle-side similarity. So I need the measures of two pairs of corresponding sides to be proportional, and then I need the included angles to be congruent. Okay, well, let's see. Here I have two sides on triangle ABC and two sides on triangle DEF, and I have the included angle. All right, well, the included angle is congruent. All right, the two included angles are congruent, so I got that part. So now I just need to see if these two pairs of corresponding sides are going to be proportional. So I need to check this pair of corresponding sides and this pair of corresponding sides and see if they form a proportion. In other words, I need to see if these ratios are going to be equal. So let's see. Let me start with AB to DE. So AB to DE is 18 to 12. And let's see, I can reduce that if I divide top and bottom by 6. 18 divided by 6 is 3. 12 divided by 6 is 2. Okay, so this ratio, AB to DE, is 3 over 2. So let me see if that's going to equal this ratio, AC to DF. So AC is 15. DF is 10. And let's see, if I divide top and bottom by 5, 15 divided by 5 is 3, 10 divided by 5 is 2, and yes, both of these ratios are equal, therefore those pairs of corresponding sides are proportional. So I can say triangle ABC is similar to triangle DEF by the side-angle-side similarity theorem. Okay, let's take a look at a few of these examples. Example number 1. And in the instructions it says, first state if the given pair of triangles are similar, and if they are similar, then if you can, state what the scale factor is. So let's take a look at example number 1. So I've got two triangles, and I'm given the lengths of the three sides of each of the two triangles, and I don't have any angle information, so the only similarity postulate or theorem I'm going to be able to use here is the side-side-side similarity theorem. So I need to find out if the ratios of all of my pairs of corresponding sides are going to be the same. In other words, I want to find out, are all of my corresponding sides proportional? Well, let's try it and see. 15 over 12. Let's see, 15 over 12, that's, if I divide top and bottom by 3, that gives me 5 over 4. And let's see, 20 and 16, those are corresponding sides. 20 over 16, and if I divide top and bottom by 4, then I get 20 divided by 4 is 5, 16 divided by 4 is 4. All right, so I'm good so far. Now I just got to check my last pair of corresponding sides, 25 and 20. Let's see what that ratio is. If I divide top and bottom by 5, then I get 25 divided by 5 is 5, 20 divided by 5 is 4, and yes, each ratio of the corresponding sides, they're all equal to the same number, 5 over 4. Therefore, all of those pairs of corresponding sides are proportional. Therefore, yes, by the, let's say yes, by the side-side-side similarity theorem. And I already know what my scale factor is, because remember, the scale factor is just the ratio of any pair of corresponding sides of similar triangles. Well, that ratio of any pair of corresponding sides is 5 over 4. All right. Example number 2. Here I have two triangles. I don't have any information about the sides, but I do have some information about angles. In fact, I have two angles in one triangle that are congruent to two angles in the other triangle, and that is the angle-angle similarity postulate. So this one, the answer would be yes, they are similar by the angle-angle similarity postulate. Notice, however, to calculate the scale factor, in order to calculate a scale factor, I need lengths of corresponding sides. I don't have any side lengths. So even though I know these two triangles are similar, I can't calculate the scale factor because I don't have the lengths of any of my sides. So my scale factor, let me just write, can't calculate. All right, example number 3. Here I have two triangles, and I've got some information about two of the sides of one triangle and two of the sides of the other triangle. I don't have any angle information. So the best I would be able to do would be able to show that two pairs of sides are proportional. But even if I can do that, that's not going to do me any good, because in order to use the side-side-side similarity theorem, I would need all three pairs of sides to be proportional, and I don't have this side and I don't have this side. So I'm not going to be able to use the side-side-side similarity theorem. In order to use side-angle-side, I would need to know if the included angle here were congruent to the included angle here. I don't know that either, so I'm not going to be able to use side-angle-side. And I don't have any other angle information, so I'm not going to be able to use angle-angle. So no, I can't say that these two triangles are similar. So I'll say not similar. And since they're not similar, I can't state what the scale factor is. So I'll just leave scale factor. I can go ahead and write that down too. Scale factor, can't calculate. All right, example number 4. So here I have two triangles. Now I have two sides here where the measures are given and two sides here where the measures are given. I also have an included angle here that I know is congruent on both of these triangles. So I may be able to use the side-angle-side similarity theorem if I can show that my pairs of corresponding sides are proportional. So let's find out. In order for them to be proportional, this ratio is going to have to equal this ratio. So let's see. 12 over 9. I divide top and bottom by 3. That's going to give me 4 over 3. Let's see if that matches with this pair of corresponding sides, 8 over 6. So if I divide top and bottom by 2, 8 divided by 2 is 4, 6 divided by 2 is 3, and yes, they are proportional. Their ratios are equal. So I've got two pairs of corresponding sides that are proportional, and the included angle is congruent. Therefore, yes, these triangles are similar by the side-angle-side similarity theorem. And I know that my scale factor, which I've already calculated, that's just the ratio of any two corresponding sides, my scale factor is 4 over 3. Now you have 4 more examples. I want you to do those on your own, and we'll take a look at your answers to those in class tomorrow.